Hello guys, welcome to my YouTube channel. I hope you guys have information about me. If you are new to my YouTube channel, here is my information. I'm Jeevita Amman, Department of PCA of Fourth Sem, studying in Shri Venkateswara College of Engineering near Airport, Bangalore Road. Today my video is about the subject of circuits and controls. In this circuits and controls, we are gonna learn today about superposition theorem and problem analysis on superposition theorem. Before going to the problem analysis on superposition theorem, I'm gonna explain you what superposition theorem states that. Now let's move on to what superposition theorem states. Superposition theorem states that in any linear circuit containing multiple independent sources, the current or voltage at any point in the network may be calculated as algebraic sum of the individual contributions of each source acting alone. During the process, when determining the output due to a particular independent source, we should disable remaining independent source and open circuiting the current source. What it states that in any linear circuits, there will be present of one or more independent source. The examples of independent source are like voltage source or current source. If any one or more independent sources like current or voltage source present in a network, if we want to find the contributions of individual independent sources through the network, we have to find individual limits. We have to disable all other independent sources while finding out the particular individual independent source and open circuiting the current source. After finding every individual particular independent sources, then we have to sum, like here we having network may be calculated as algebraic sum of the individual contributions. We have to find the individually contributions to the network, and then we have to algebraic sum. We have to add all the independent source which we have found out in individually. This means superposition theorem. Now let's move on to problems on superposition theorem. Okay, now let's move on to the numerical problem on superposition theorem. Let me read out the question. The Wheatstone bridge in a circuit shown in figure is balanced when R2 is equals to 1200 ohm. If the galvanometer has a resistance of 30 ohm, how much current will be deducted by it when the bridge is unbalanced by setting it to R2 is equals to 1204 ohm. Now you can see the circuit diagram here. So let's move on to the solution of this. Now let's move on to the solution of that problem. To find VOC, we are interested in the galvanometer current, hence it is removed from the circuit to find VOC, and we get the circuit shown in the next slide. Hence we have to find your I1 and I2. We know the formula I is equals to V by R. So now to find I1, V is equals to 120 here in the circuit given, and here 900 plus 600 because R1 and R3 are connected in series. So we have added, we'll get 120 divided by 1500 ampere. Next, to find out I2, same formula V by R. The voltage current will be same throughout the network and divided by 1204 plus 800 because R2 and R4 are connected in series. So here it is added is equals to 120 divided by 2004 ampere. Now give me a minute. Now let's apply a KVL clockwise along the path 1204 ohms to 900 ohm we get. Now we have to apply KVL from here to here. After applying KVL, we'll get the equation 1204 I2 minus VT minus 900 I1 is equals to 0. Vt is equals to 1204 I2 minus 900 I. 1000 is equals to 1204 into 120. Here we have found out the I1. So substitute this I1 and I2 in the equation. After substituting, we get 95.8 millivolt. Next, let's move on. Hence I said before, we have to remove galvanometer here because it is an independent source. Next, to find RT, deactivate all the independent sources and look into the terminals A, B. Determine the Thevenin's resistance as shown below in figure. As Thevenin resistance says that we have to remove all the voltage sources. Here we are having independent source. Here we was having voltage source, and we was having galvanometer. Okay, now after applying Thevenin's theorem, this 900 ohm resistors and 600 ohm resistors which are connected in series, it will be connected in parallel, and here 1204 ohms and here 1800 ohm which are connected in series. Next it will be connected in parallel as shown in this figure. After connecting all resistance in a parallel, we have to find the value of R. To find R, when the resistance are connected in parallel, we have connected 600 ohm parallel to 900 ohm plus 800 ohm parallel to 1204 ohm. We have connected all these resistance in parallel. We have the resistance value to find when it is connected in parallel. Now R1 into R2 divided by R1 plus R2. So here we have applied that formula. 900 into 600 divided by 900 plus 600, it is equals to 1500. Next, here we have used plus 1204 into 800 divided by 1204 plus 800. Here we get 2004. After simplifying it, we will get 840.64 ohm. Now, hence the Thevenin's equivalent circuit consists of 95.8 millivolt source in series with the 846.4 ohm resistor. If we connect 30 ohm resistor galvanometer resistance to this equivalent network, we obtain the circuit shown in figure below. To find the galvanometer current when it is having 30 ohm resistor, we are having the voltage source 95.8 millivolt, so here it is 10 to the power of minus 3 divided by 840.64 plus 30 ohm ampere. After simplifying it, we get 110.03 microampere. So let's move on to the next question. Problem number 2. For the network shown below in figure, apply superposition theorem and find the current I. Now let's move on to the solution. Open the 5 ampere current source and retain the voltage source. The resulting network is as shown in figure below. We have to remove this 5 ampere current source and we have to keep this J20 volt voltage source same. Now the impedance as seen from the voltage source, the Z impedance is equals to Z 4 minus J2 plus 8 plus J10 minus J2 divided by 8 plus J8. It is in the form of polar form. After simplifying it, we'll get 6.01 minus 45 degree ohms. Now to find I, we have J20 divided by Z is equals to 3.328 135 degree ampere. Now next short the voltage source and retain the current source. The resulting network is as shown in figure below. As I said in the superposition theorem, we have to find out how the independent source contribute to the network. So first, initially we have take out the 5 ampere current source, and in the second case we will take out the voltage source, keeping this 5 ampere in the circuit. Now apply KVL for mesh 1 and mesh 2. Will get 8I1 plus I1 minus 5 of J10 plus I1 minus I2 minus J2 is equals to 0. After applying KVL for the second mesh, we'll get I2 minus I1 into minus J2 plus I2 minus 5 into minus J2 plus 4I2 is equals to 0. Next, move on to the further simplification. After simplifying the equation, we'll get 8 plus J8 into I1 plus 2JI2 is equals to J50, and another equation is J2I1 plus 4 minus J4 into I2 is equals to minus J10. After simplifying, let's call this equation number 1 and let's call this equation number 2. After simplifying these equations, we'll get the value. Since we are having J, we have to simplify this in the form of polarity form. So we'll get 2.897 into minus 2396 amperes. Since IA and IB are flowing in opposite directions, we get I is equals to, when the currents are flowing in the opposite direction, we have to subtract it. When the currents are flowing in the same direction, we will gonna add it. Now in this case, currents are flowing in the opposite direction. I is equals to IA minus IB. So by subtracting it, we'll get 6.1121 into angle 144.78 degree ampere. So I hope you guys have understood the superposition theorem and two numericals based on superposition theorem. If you have guys liked my video, please like, share and subscribe my video. Thank you. Let's meet soon in the next